Hey guys, today we're going to focus on work and power. Now this should be a brand new topic for everyone, so this is going to be a little bit more in-depth of a slide of notes. So first off, work. In science and in physics, work is the product of force and displacement. So I know that my kiddos, we talked about the idea of you can apply a force as much as you want to, but if that object does not move, according to physics, you haven't done any work. So in order for it to count, you have to have a force applied and a displacement or a distance moved. So down here we have this equation. Work is W, and work is measured in joules. F is our force, and our force is measured in newtons. And this lowercase d is our displacement, and it is measured in meters. So this is a simple equation. It's just force times distance. Now above this, I'm going to give you our triangle. In my class, we really like using these, so I want to make sure that I give you an option of doing that. And drawing a triangle online is a lot more difficult than in class. So the top of our triangle is W, the bottom left is our force, and the bottom right is our displacement. So again, my kids know how to use this. If you don't worry about it at all. But this triangle is available for you if you need it. So here's an example. If you apply 100 newtons of force to an object and move it 5 meters, how much work is done? So over on my left, we're going to list our knowns and unknowns. We have work equals, force equals, and displacement equals. It's asking how much work is done, so this is our question mark. Our force is 100 newtons based on the units given above, and our distance is 5 meters. So if we use our basic equation, is force times distance, work is 100 times 5, and our work is 500 joules. So that one's really easy. All you have to do is multiply. Now, if I give you the work value and ask you to solve for force or distance, that's going to change, and instead of multiplying, you're going to be dividing. So next we're going to move on to power. When we talk about power, it is the rate at which work is being done, meaning it's a ratio. We have to have our work value and we have to have a time value. So we calculate power using the following equation, and I'm going to give you two actual equations to help you out. Power is work over time. Power is measured in watts. Work is measured in joules, and time is measured in seconds. Okay, so we have that basic equation, but we can also have a second equation that instead of giving you the work value already calculated, you may have to calculate it yourself. So it's force times distance over time. So the last equation on the last slide, put on the top of the fraction bar with time on the bottom. So again, this is how you would calculate power. I'm going to show you two separate examples so we can do both ways. If you do 400 joules of work in 5 seconds, how much power is exerted? So since we have work is 400 joules, time is 5 seconds, we can use that first equation to solve for power, which is our big fat question mark. So P equals W over T. Power is 400 divided by 5, which is 80 watts. Okay, so that's pretty easy. And I forgot to give you the triangle on the last page, so I'll do that here. We have the triangle, we have W at the top, P at the bottom, and T on the other side. Okay, so here's your triangle equation if you feel more comfortable using that one. Now we're going to do one more example problem. This one, instead of giving you work total, I'm giving you a force and a distance. So over here we're going to write P equals big fat question mark, force, distance, and time. So the force is 100 newtons. All we have to do is match our units. The distance is 5 meters, and the time is 4 seconds. So we're going to use that second equation of power equals force times distance over time. Power equals 100 times 5 over 4. So I'm going to go ahead and do the top part first. It is 500 over 4, and that gives us a power of 125 watts. So it's just combining the two equations, the first one and the second one, to get this third equation. So what we're going to do is practice with this a little bit, and you will see it again on your assessment. See you guys soon.